All right, Algebra 2, today we're going to be focusing on zero, negative, and rational exponents. For those wondering what rational means, we basically mean fractions, more or less, just fractions. So these are the rules redone over and over again. You now have, this will be your third set of notes that has this reference sheet on it. You are responsible for these rules. I'm not going to go through this because I've already done it in previous ones. But if you want a quick example of how the number 1 would work, b is a placeholder and m is a placeholder. So it could look something like this. If I had x to the 7 times x to the 3, you see that, then what I would end up with, see my b is for my base. I'd have x to the 7 plus 3 is 10. So if you missed any of these past Schoology videos, go to yesterday's, go to Friday's, and I go through these rules more extensively, especially on Fridays. But with that, I'm going to keep moving on. We have things to cover today. So I'm going to work a bunch of examples. All right, now I'm going to start with example 1. Here's the deal. This is multiplying bases together that have the same base and then have exponents. We're going to deal with fractions now with the exponents, and I know y'all hate those, but it's the same rule. It's the same rule. The same rule is if you have two bases that are same, in this case b and b, and you're multiplying them together, what you're going to do is you're going to add those exponents. So you end up with b to the 1/4 plus 1/4 in there. Now, obviously, I don't like this answer. I don't like seeing it like that. So what do I want to see? I want to see your work on your fractions. How do we do this? You literally add them together. I included a video at the very end of this. It's a couple minutes. It's this like lady who's going through the 4 rules of fractions. You can go check those out if you don't remember those. How we add fractions, for those who know and those who don't know. You basically have to have the same denominator, which check it out, I have a 4 here. And then once you have the same denominator, then you add the numerators. So 1 plus 1 is 2. Keep the denominator and then see if it simplifies or not. And it does. It simplifies to 1/2. So this answer actually comes out to b to the 1/2. That's how I got it. The same rule. So now notice how you have to know your rules for your exponents and you have to know your rules for fractions. And I believe some math teacher since August has been screaming at y'all to get your fraction rules, times tables, and rational rules. And here we are, a lesson that deals with all 3 of them. And are y'all going to struggle on the new stuff? Nope, you're going to struggle with all the fractions and whatnot. I cannot stress to y'all enough that I don't have any authority to make y'all memorize this stuff. I don't have the time. You were supposed to have this done. Get it memorized. Get your fraction rules memorized. Get your times tables memorized. Like, just do it. It's not that hard. It's a lot harder to take math classes with that stuff not handled. All right, moving on to this one. Check it out. This is a squared, b to the 2/3 times a to the 4th, b to the 1/3. Now, this is what I see here. I see an a and a b, so I know I'm going to end up with an a with some sort of exponent up there, and I'm going to end up with a b as well with some exponent up there. These are now multiplying next to each other. So you've seen problems that look like this, right? That means multiplying next to each other. So what's the rule for exponents when they're multiplying? Well, we add. 2 plus 4 is 6. And now I have to add this. 2/3 plus 1/3. All right. 2/3 plus 1/3. Again, rules of fractions. You have to make sure the denominator is the same, which it is, and then you add the top, the numerator. 2 plus 1 is 3. 3 divided by 3 it simplifies down to 1. So you can go ahead and put the 1 in your answer, so I know you know. But if you didn't write that 1 in there, it would still be correct. Because when there's no exponent, it means there's a 1 there. So that's that for the problem. This one is also saying multiplication. Remember, the rules for multiplication don't change with normal numbers. So this is saying 4b to the 4/3 times 2b to the 7/3. So our number rules stay the same. So we're going to go 4 times 2, which is 8. I'm going to end up with a b of some sort, but now I have to add this together. So my rules for exponents, 4/3 plus 7/3. So 4/3 plus 7/3. 4/3 plus 7/3. I have to make sure my fractions are the same. My denominator, I mean. That stays, and then I add the top. 4 plus 7 is 11, and that cannot simplify. 11/3 cannot simplify, so you end up with 11/3 in your answer. So that's it. Let's go to number 4. Check it out. This is pretty simple. This is this whole thing times this other thing. The number rules stay the same. We got 6. And then I know I have an x. What do I do with my rules? I have to add together 5 plus 1/2. Well, how do I do that? Well, remember, you have to get a common denominator. So there's multiple ways to do this. I'm going to go ahead and shove a 1 underneath this 5. What is my common denominator at this point? It's 2. So it's real quick to do this. You're going to set up another fraction down at the bottom. Your denominator is 1 times 2. You basically just multiply them together. Now you can multiply 2 times 5, which gives you 10. And then, of course, I'm going to multiply this thing over here, 1 times 1, which is going to stay 1. So you'll notice I did not change this fraction. 1 over half stayed the same because the denominator stayed the same. And then I changed this fraction to 10 over 2. And what's the rules? Now you add them. You add the numerator and you keep the denominator. So you end up with 11 over 2. And again, if you had your rules for fractions, this wouldn't be a big deal. This lesson, yeah, you're supposed to know your fraction rules. I wish y'all'd learned them. And again, go to the video that's on Schoology. It's the very last one. It links to a lady who gives you a quick tip on how to solve every single operation. So now I'm going to have this be my first main lecture with a few examples, and then I'm going to solve the rest of the examples on another